I'm going to use 5 patterns to show lots of things about indices. Let's dive straight in. Let's look straight away at 9 squared. 9 times 9, that's 81. I'm going to start decreasing this number by 1 each time. I mean the power by 1 each time. 9 to the 1, that's just 9. Because it's just 1, you just write 1 9. What about 9 to the 0? Okay, let's look at this a couple of ways. The first way I'm going to look at it is, what if you had 5 divided by 2 times 5? You'd cancel the 5s, wouldn't you? What would be left at the top? You'd leave a 1, wouldn't you? Oh yeah, because if you cancel timeses and divides, you get left with 1. That's what you leave behind. You leave 1 behind. And here we've got a pattern involving timeses, so that means you have to leave a 1 behind. That's one way of thinking about it. We'll look at another way of thinking about it in a moment. What's 9 to the minus 1? You probably know it's 1 over 9. If you want a little proof of that, each time you go up by 1, you times by 9. Which, by the way, is the reason that this has to be 1. Another reason that number there has to be 1. It can't be 0, it has to be 1 because 1 times 9 is 9. Well, this pattern continues as you change the power by 1 each time. So it has to be something that times by 9 makes 1, which is 1 over 9. And often my students stop me at this point and they like to try and work some of these things out themselves, or they try to do it for another number. Well, guess what? We're going to do it for another number. So you could have a go at this one on your own if you like. Maybe pause the video. Okay, I'm just going to go for it. What's 4 squared? That's 4 times 4, which is 16. What's 4 cubed? That's 4 times 4 times 4, which is 64. Notice that's just being times by 4 as the power changes by 1. 4 to the 1 is 4. 4 to the 0 is 1, because whenever timeses and divides cancel, they leave a 1 behind. And that's a quarter. That's 1 over 16. I'm just going to draw attention to a couple of things now, and then we'll do the next one. Let's draw attention to a couple of things. Notice, let's go in the other direction now. That's dividing by 4. That's dividing by 4. That's dividing by 4. That's dividing by 4. That definitely makes sense, yeah? Because 1 divided by 4 is definitely a quarter, because it's what by definition. And so on, and so on, and so on. Okay. A lot of people find it's helpful just to see that slightly larger pattern, because this top section here helps a bit more, particularly helps seeing this pattern of what the power means. So it's the number of times you write the number 4. Oh look, you write it twice here, and here you write it 3 times. And here you don't write it at all, but we write a 1 because we're dealing with times and divide, which means if everything cancels you leave 1 behind. Let's just look at what happens with the fraction. Do you know what? I'm not going to keep doing that. So that's 16 over 81. That's 16. That's not. That's 4 over 9. If you do it to the 0, that's just 1. If you do it to the minus 1, that's minus 9. No, whoa. That's 9 over 4. Such an easy mistake to make, isn't it? But remember, this minus is a code. It's telling you to flip it upside down. You might have learnt it as being the inverse. I actually don't teach it. If I'm teaching people that have never seen it before, I do not teach it as the inverse. I teach it as flip, because I immediately teach it with a fraction. And then later on, if you got the number 7, say, I just say, well, turn it into a fraction. And then when you do it to the minus 1, it'll be 1 over 7. Anyway, whatever. And then if you do it to the minus 2, that'd be 81 over 16. So a nice little practice there of how it works if you've got fractions. Now, this is a real it depends. Some students really like this. Other students is not quite so useful. So I'm just going to fill in and leave some gaps. Now, there's a kind of logic to this, which is, well, if we're just changing the power by the same amount each time, I guess we're just going to halve the amount we're changing it by. So that would have to be minus 3 over 2. That would have to be minus a half. That would have to be a half. This, by the way, is how I teach it the first time if someone's never seen these things before. So I'm going to pretend you don't know what they mean. Well, do you remember when that was times by that step was times by 9? Well, then the smaller step must be times by times by 3 and times by 3. So each little step must be a times by 3. Which means we can now write the answers in, which I'll do in blue. So that must be 3. And that must be 27. And obviously that must be 1 over 3, 1 over 27. So I think that's quite interesting. We've managed to demonstrate with a pattern that 9 to the half is 3, which of course probably quite a lot of you watching this video already knew, because you knew that the square root of 9 was 3, and you knew that 9 to the half meant square root. But I think it's quite interesting, and often my students find it quite interesting, that, hey, look at that. We just managed to show that a different way using the pattern. I love patterns. I think it's a really good way of learning a lot of things in maths. Let's just finish off. Final little revision, just because it's a little stumbling block for some people. That's a quarter. By the way, that's because it's a half times a half. And 1 times 1 is 1, and 2 times 2 is 4. If you do it to the power 1, that would be a half. Do it to the power 0, that would be 1, because times and divide, everything cancels to 1. That would be 2, and that would be 4. Thanks for watching. Hopefully that was helpful.